Okay, so in this video basically I'm going to show you how this application works, okay, or I'm just going to show you some circuits, a virtual circuit essentially. Right, so I'm going to put a 12 volt battery, okay, and then I'm going to connect it to a 6 volt battery, okay, and I'm going to have a switch, okay, so let's connect these up. Now this 12 volt battery will supply electrons with 12 volts. This lamp can only take 6 volts. So let's see what happens. So I connected the battery. Let's see what happens when I turn the bulb. You saw the light bulb exploding, okay, and breaking. Right, let me get rid of it. Let me replace the bulb. Okay. But this time I'm going to add a fuse. Okay. So I'm going to add a fuse to the circuit. I'm going to get rid of this wire here. Sorry. Just going to rotate this. Okay. So, this time, when I connect up the circuit, do you see what happens? The fuse broke and the lamp is still intact. And this is one of the main applications of fuses, okay? And there's a fuse present in every, or most connectors that you plug into your electrical devices or appliances, because it's to protect your appliance, okay? So instead of your appliance breaking, your fuse breaks instead. So and this is a series circuit, okay? So now if I just get rid of this fuse, and I'm going to now replace my lamp with a lamp. I'm going to replace it with this 12 volt lamp, which won't explode this time, okay? I'm just going to connect up my circuit like this, but this time I'm going to bring in an ammeter and a voltmeter. So, remember what I said in an earlier video, that you have to connect the ammeter in series. So what do I mean by that? Well, I mean this. One wire is connected to one end of that circuit, and another wire of this ammeter is going to be connected to this end of this circuit, okay? Now, these are multimeters, meaning they can act as ohm meters or resistance meters, and voltmeters or potential difference meters, and ammeters to measure the current, okay? Now, how this application works, basically you change the setting here. So this is now reading the current, and this is reading the voltage. Okay, notice 12 volts supplied by the battery, and it's passing 0.83 amps. Don't worry about the negative sign, it's just the wires are placed in that way. If I swap them around, it'll be positive, but don't worry about that. So we've got 0.83 amps passing through this circuit, and the lamp is reading 12 volts. Okay, so I now connected a variable resistor to this circuit, and see what happens when I move it up and down. Okay, I'll move the dial up and down. You can see the brightness of the bulb increasing, so it's maximum brightness, and it's decreasing to have a low brightness. And look at the voltage as well. See, it's got low brightness. The voltage is very low. When it's got high brightness, it's almost 12 volts, okay? And you can also see in the current also decreases when I change the variable resistor setting, okay? So, again, I won't build a series or a parallel circuit for you, but you saw in the previous diagrams that I drew that basically voltage gets split in a series circuit, but stays the same when in parallel, but current stays the same when it's in a series circuit, but splits when it's in parallel. And also, finally, notice these arrows are going from positive to negative. It's because it's showing, this is showing the conventional current. And for historical reasons, scientists thought that charge was positive in the olden days, and therefore they thought that current went, or charge went from positive to the negative sign. Okay, so that's why these arrows are showing, are going from the positive to the negative sign. However, the difference between conventional current and the direction electrons travel at this moment, you can see the minus signs, okay, going around. So that's the direction that electrons travel at. However, if I change the setting, the arrows are now going the opposite direction, and that's showing the conventional current, okay? And for historical reasons, conventional current was thought of because they thought the charge was positive, and therefore they thought charge went from the positive direction to the negative charge, to the negative plate of the battery, okay? But you just need to be aware of the difference. Conventional current goes from positive to negative, whereas the direction of electrons go from negative to the positive end of the battery. And that's it.